This video is going to cover 7.2, which is right triangle trigonometry. Okay. Brief reminder about the quadrants. Okay. We're starting on the top right and we go counterclockwise. Um, we're going to be using that a lot. Now, we are going to focus on quadrant one, and given any angle A in standard position, we can create a right triangle by drawing a third side opposite to that angle A. Um, so in this first one, you'll see that you have angle A right here, okay? Um, and we can work with the opposite side and what we call the hypotenuse side, okay? And that is going to be used with sine, okay? This is sine. These are called trigonometric ratios, okay? Then we can also work with the adjacent side and the hypotenuse side, and that's going to be your cosine. Or we can work with the opposite side and the adjacent side, and this would be tangent. So a memory device that you can use is SOHCAHTOA. So S is for opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. Okay. So find the exact values of tangent of A and tangent of B, where A and B are shown in the triangle below. So if we're interested in tangent of A, okay, so tangent of A is opposite over adjacent. So that's going to be this guy, 56, over this guy, 33. Okay. If we're interested in tangent of B, let me erase so that I can show you what that looks like. We're going to work here. We're going to go opposite 33 over adjacent 56. Okay. Now, if we want to do that for sine and cosine, it'll look similar. However, we do need to find the hypotenuse. Okay, we do need to find the hypotenuse. This side is missing, so we do need to find that side. So 33 squared plus 56 squared equals c squared. Oops, I should have opened the other one, but it's fine. Let's see, 33 squared plus 56 squared. Okay, so then we have the square root of this. Okay, that's going to be 65. Okay. Starting with sine of A, so we're here, we're going to go opposite and hypotenuse. So sine of A is opposite over hypotenuse, which is 56 over 65. Okay, if we're interested in cosine of A, that is adjacent over hypotenuse. I'll use blue, so that'll be 33 over 56. Sorry, 65. Okay. There's three other ways to measure the shape of an angle. It's called the reciprocal trig functions. They're just the reciprocals of the three basic trig functions from earlier. So this one is called cosecant. Okay, cosecant. It is the opposite of sine, so it's the hypotenuse over the opposite side. Then we have secant, which is the opposite of um, cosine. So we have hypotenuse over the adjacent side. And then we have cotangent, which is the adjacent side over the opposite side. Okay. So opposite, oops, whoa, where'd we go? Here we are. So this is opposite of sine, opposite of cosine. I want to say opposite, but it's reciprocal. Opposite of tangent. Okay. All right, let's find cosecant, secant, and cotangent of B. Okay, now we're over here. We said this was 65. Okay. So cosecant of B is going to be 65 over 33, right? Remember that it's going to be the hypotenuse over opposite side. Secant of B is the reciprocal of cosine. So we're going to have 65 over 56, which was the adjacent in the denominator. And then cotangent of B is the adjacent side, whoops, the adjacent side over the opposite side. Yeah. Oh, excuse me. Sometimes we can be lazy and drop the parentheses. So in this next one, you'll see that it just has cosecant of B with no parentheses, totally fine. Let's go ahead and draw a triangle to represent this situation. Okay. That tells us this is going to be B, which tells us we have 7 and 12. We don't know what this value is, right? We need to use the Pythagorean theorem to find it. It's going to be approximately 9.7 or the square root of 95. Um, From there, we can find cosecant B, cotangent B, and secant B. So cosecant of B is going to be 12 over 7. Secant of B is going to be 12 over root 95. And cotangent of B is going to be root 95 over 7. Okay. We also have these triangles called special triangles. There's two kinds. There's the 45, 45, 90, as well as the 30, 60, 90. So the first one is half of a square. The second one is half of an equilateral triangle. They have special characteristics, and it's definitely worth feeling comfortable with them. We're going to be working a lot with these guys. Okay. Now, if you look at the first one on the left, you'll see that it has two sides that are 45 degrees, okay, which means that those corresponding sides are also the same, okay? Now, if we're interested in finding sine of 45 degrees, from either side, we would have the opposite and then the hypotenuse, okay? So x over x root 2, which is the same thing as 1 over root 2. The same will be said for cosine of 45 because it is now next to the 45 degrees. Okay. For tangent, we would have x over x, which would be 1. Okay. And for secant, let me choose another color. For secant, we would have x root 2 over x, which is root 2. Okay. These relationships are going to be really important in this class. I'll just go ahead and highlight them. When we look at their ratio of values, we think x to x root 2 or 1 to root 2. Okay, that's what this is essentially saying. And we can multiply by any factor or divide by any factor, and that ratio would still hold true. Okay. let's take a look at what happens with the 30, 60, 90 triangle. It's similar, right? It has its own rules, but what we're going to do is really similar to what we just did. Okay. So for sine of 60, we're going to be opposite and hypotenuse. So x root 3 over 2x, which is root 3 over 2. Okay. Cosine of 60 is going to be x over 2x, or 1/2. Okay. And then tangent is going to be opposite side and the adjacent side. So x root 3 over x, which will be the same thing as root 3. Okay. Now secant, my last color here, secant is the opposite of cosine, so that's going to be 2x over x, or 2. Okay. Now again, these are going to be really important numbers to keep in mind. What we can do with the ratio again is say x to x root 3 to 2x, or 1 to root 3 to 2. Similar to before, we can multiply by any factor or divide, and that ratio will still hold true. Okay. In radians, it's the same exact thing. Okay, it's the same exact thing. Let's briefly talk about complementary angles and cofunctions. In any triangle, the sum of the angles are going to be 180 degrees. Okay. Um, and the measure of a angle is 90 degrees. We know that. And that means the other angles are going to be acute or less than 90 degrees. Okay. And then if A and B are two acute angles, then they're going to add up to 90 if it's a right triangle. And then A and B are complementary if they add up to 90. Complementary. Okay. Um, we can also call them complements. Either one works. Now, suppose that A and B are two complementary angles in this right triangle. So that means they're going to add up to 90, which you see in that little box in the corner. Opposite and adjacent sides are switched. Side A is opposite to angle B, but adjacent to angle B. So notice that this is what they're talking about. Okay. Everything is like in the opposite corner of other stuff. Okay. The word complementary is when we have the prefix co, and it refers to these rules below. So you have complementary sign can be written as cosine of theta equals sine of 90 minus theta. Complementary tangent would be 90 minus theta of tangent to get cotangent. The same for secant. Okay. And then the complement of a complement of A is equal to A itself. So that would be like saying 90 minus this complement would be A. Okay. All right. So cofunctions always come in pairs. So for sine and cosine, we would pair up cosine and for sine and cosine, we have cofunctions. For tangent and cotangent, we have cofunctions. And for secant and cosecant, we have cofunctions. So at any given time, you could rewrite a function in terms of another function. Okay. So for example, consider that cosine of 79 is about 0.1908. We could find a close approximation for cosecant of 11 degrees using a cofunction identity. Okay. So for cosecant of 11, we could write that as 1 over sine of 11, right? Which is can also be written as cosine of 90 minus 11, okay? Which is 1 over cosine of 79, which is what we just had earlier. So 1 divided by 0.1908 is going to be approximately 5.241. Okay. So this was the reciprocal. Rho, and this was a cofunction. Okay. Let's talk about this applied geometry question. A ladder of length 7 meters leans against a vertical wall and it forms an angle of 30 degrees. Let me go ahead and here's this wall, here's this ladder. Okay. It forms an angle of 30 degrees between the wall and the top of the ladder. So this right here is going to be 30 degrees. What is the distance along the ground between the bottom of the wall and the bottom of the ladder? Okay, so what we're unsure about is this right here, and the ladder is 7 meters long. Okay. Now there's a visual, like if I were to just draw it flat, we wouldn't know what this is. We know that this is 7, and we know that that is 30 degrees. Okay, so if we're interested in finding x, we're going to use 30 degrees, and I'm going to go ahead and use sine because I have the opposite side and the hypotenuse side. So x would be equal to sine of 30 times 7, okay, which is going to be about 3.5 meters. Okay, one last question. Standing at an unknown distance from a 140-foot tall rock formation, a geologist determines that the angle of elevation to the top is 12 degrees and that the angle of depression to the bottom is 2. How far is the geologist from the rock formation? Okay, all right. We are going to draw a beautiful rock formation. Here is my rock. I was an artist in a past life. Okay. It looks like we are far away, dating an unknown distance, so we don't know. This is our unknown distance. It looks like this guy is 140 feet tall. Okay. And then the angle of elevation. So let's draw that would look like. Angle of elevation is here, is going to be 12 degrees. And let's choose another color, maybe purple. The angle of depression is 2 degrees. Okay. It's obviously not to scale, but that's fine. Okay. We're interested in finding X, how far that geologist is. Okay. All right. So we have two options. We have two angles to work with. It does not matter which one you choose. I'm just going to work with 12. I see that I have opposite of 12 and adjacent to 12, which suggests I'm going to use tangent. So opposite over adjacent is 140 over x. I'll go ahead and bring that x over by multiplying, and then divide by tangent of 12. I'm going to throw that in the calculator and get 658.6 feet. And that should cover it for this section.